Disclaimer before I start. When we scheduled this meeting, we didn't know that DeepSeek will launch an open source model and generate a huge focus that surrounds open source models and will help me to talk and will boost my this topic. So thanks for the God of stochasticity and the Chinese. Several things about myself. Second master degree in applied math, many years in the world of AI. I'm representing Israel in the standard committees of quantum computing and smart contracts. I have several papers about AI and AI ethic, and what important most, for the guys from Apiro. In 2014, I got an email in the LinkedIn from a guy I didn't know named Natan Katz that offered me to join him for an adventure. And I said that since I don't know him, it's probably a scam. And after 6 months, Natan Katz became rich, and I still had to check my scam detection algorithm. A joke about myself. In the last year, or nearly a year, I'm a co-founder of Lumina Security that deals with open source models, and this is what we are going to talk about today. Okay. No. Okay. So those of you that are old enough and used to work as data scientists in the previous decade, and those of note and attended the lecture of Arnon and are now familiar, know what is the life cycle of developing a commercial model in the previous decade of AI. A guy from the line of business decided that he has to extract more BI from its data, where its data is often customer data. He goes to the guy from the head of AI. The head of AI tell him, of course, we can do it. And then what they do, they establish a new environment and migrate the data because the data scientists that they don't have access for the customer's data. And then they start to do some dark labor in cleaning the data, and the C-levels are anxious because the data scientists gained a lot of money comparing to the rest of the R&D people. And after they clean the data, there is a session that they say that they need more data, or that they say that they have an accuracy of 99%, and then the line of business come and say, oh, but how does it leverage us financially? And after this cycle it was over, there was the cycle of how to deploy the model, because the model was trained in Python, and the software is written in Java. And we didn't have yet Onyx, Keras.net didn't work well with the multi-thread. So what they used to do often is simply develop the inference in Java. A cumbersome process, but that's the way people used to work. And then on 2017, there was published Attention is All You Need. For the younger people around, the notion attention wasn't defined in this paper. It was defined already in 2014 by a guy, and I forgot his name, that sort of improved his LSTM mechanism. But their attention was that this was the breakthrough, the main breakthrough, where the people of Google has shown a very unintuitive claim. If you take a huge enough model and bombard it with the huge enough data, you will have an outstanding machine. Something that it is extremely not intuitive. This outcome generated a gap that was filled by a set of websites that called Model Zoo. These were websites that people uploaded models based on the massive amount of data, which most of the organization couldn't have. If you think about, I used to work that time at NICE, we wouldn't able to aggregate the amount of text that Google had. So it became way simpler to take a pre-trained model, fine-tune it as Arnon and Elad do right now, and they presented in the previous lecture, or even simplify or use the models that are pre-trained in an upstream task into a downstream task for different reasons. It is very easy because Hugging Face offered a very simple open source code, and life became way easier. And it was sort of a revolution when we think about AI in its commercial aspect, and if you don't think about Google and Microsoft, but about mid-level organization. A word about security at that time, because I'm going to talk about Lumini. Questions about security in this time, I mean, end of the previous decade and the early years of this decade, were security about AI focused in two directions. One was developing AI tools for security. A leading firm was an American firm that called Trojan AI, that as far as I know, they made sort of a pivot in the passing year. I'm a startupist, I follow all my competitors. And the other direction that was more relevant was the issue of protecting the pickle files. Now, pickle files are surrounded with operational code, and this code tend to be vulnerable. Now, firms like Hidden Layer or Protect AI came with the solution that we will protect the operational code and claim that we protect the models. It was a great solution, but in the last 1 or 2 years, it becomes nearly obsolete. And why is that? Because there is the appearance of a safe tensor format. Safe tensor format saves directly the tensors of the model and doesn't have a wrapping code. And what we do in Lumina is we handle such models as well, but since I'm sort of doing a historical survey, so at that time, Hidden Layer more Protect AI even before, were able to scan pickle files or the format of Keras that I don't remember its name, but it's not exactly a pickle, but they can do it nowadays. Will you work? It somehow boycotts me. Okay. No, I ran it fast. Okay. Thank you. 2022, ChatGPT arrived, OpenAI, and also Anthropic launched Claude. As we all know, it was a mega revolution. Why it was a mega revolution? Not because there was something innovative in their algorithms. There wasn't. But it took the AI from being a special property of people that do data science and move it to the entire world. A person with no technological background can go and use AI for planning its vacations, handle problems with its kids, or or consult how to buy a present to his spouse. AI is accessible to everywhere. But there was another issue. AI, C-levels and boards began to require from their organization to include AI in the solutions. And when such thing happened, the CISOs all of a sudden decide to begin to ask questions about what is AI, or what AI is actually. The first real sign of this happened in summer 2023, where the OWASP LLM appeared. OWASP LLM focused on list of risks that organization is exposed to due to the usage of LLM, particularly ChatGPT, but not only. Clearly, the main risk that people think about them was data leakage prevention. You are the user. Sorry that I sound like Heidegger right now, but you are the person in an organization, and you talk to the model, and you may cause risk, and you may cause data leakage. Startups that handle with it are last example for startups that handle DLP, or it Israeli Lasso at AIM. And there was also another solution, which is sort of a firewall solution that check the input, check the output, find things that are improper. A firm that does things like that is Gnostic. And I can tell you that this pitfall of AI is always LLM is something that nowadays VCs have difficult to understand that it is wrong. I mean, when you talk about models, they always think about LLM. Okay. No, I didn't mean. Okay. Okay, it works. So now we are in the question, what is better? Using open source models like people do in Apiro, or using ChatGPT like in my previous place in Checkpoint? It's a broad discussion, and undoubtedly I won't cover it all right now, but let's focus on several components. So first thing is cost. The people, the supporter of ChatGPT can tell you now silently, he cheats because SageMaker costs more. Okay, so it will be like that. But basically, when you use open source, you pay for the cloud services and the income of the data scientists. When you use Azure OpenAI, for instance, you pay for tokens, and tokens cost. Well, this algorithm works. Some other advantages of open source is the privacy. You don't hand over your data to Azure and rely on their security services. And as I sort of said before, it is extremely easy. You have a lot of models in Hugging Face that can solve nearly every problem. So you can either take models or take and fine tune, or take and play it in any way you wish, but it's extremely easy because the required code is very small, and the BI needs, and you can fulfill nearly every BI needs of your line of business, because if the model is there, it is easy to modify. I think that Arnon explained it very well when he talked about the way you fine-tune the C and Orca. It's okay to mention you, yeah? So let's talk about cybersecurity. So the first thing that we can see about Hugging Face, and Hugging Face, it's Hugging Face and every other model zoo, is these spooky graphs. This is x-axis is pretty clear, it's the year, but this is the amount of users. This graph was made in May by one of my partners, and it totally was wrong because Hugging Face nowadays are in about 5 million users. And when you observe this silhouette and you compare it for the process that took place for GitHub more than a decade ago, it ended with a Ruby Rail breach. And as an outcome of Ruby Rail breach, we got firms like Snyk that aim to handle vulnerabilities in open source software. So if you observe this and this, and we are all data scientists in some sense, and they think about correlation, let's say that we have a non-neglected probability to see here a breach somewhere. I didn't say that it will happen, I said that there is a non-neglected probability. Okay? Now we move to some more practical questions. If we compare Hugging Face and the typical data scientist. So Hugging Face, you can upload every model that you wish and download every model that you wish. They don't ask questions. They have sort of a security checks, but it is very fragile. Moreover, we found out that if you are a good hacker, you can upload models to repositories of proper organizations such as Meta or Intel. Because the process there is that the sitting data scientist, someone let's say like Ella, that among her duties, which are many, she has also to confirm a model to the repository. You can assume that it is not her very first concern. Okay? On the other hand, we have the data scientists. We don't really care about security. Or about drinking coffee with the CISO and then tell him about what bothers us. Okay, this is the wording of the previous slide. Now the main question is about the CISOs. So I can tell you that I see that CISOs begin to understand me now. When I work several months, I can generate sort of a graph. We see that CISOs more care about open source models and AI, but they are still in a learning process. Typical comment, and the first one is CISOs typically don't talk with data scientists and vice versa. And I had the opportunity to show many CISOs that told me, we don't use Hugging Face, to show them that they have an organization in data science, not talking about regular employees that simply upload models. The next thing is the second clause say that they can block Hugging Face, but if you don't want to pay for OpenAI and you block Hugging Face, open source, you will remain without AI. And I believe that most of the CEOs won't support this strategy. CEOs typically listen to their neighbors and that say, hey, I use AI. It's like any Friday talks that we have. The last 2 points, I wrote only one, but CISOs concerned a lot about data when PI and PII, but less about the risks that come from model. For instance, if you think about the way to hack a model that's approve or disapprove a mortgage in the bank, this is something, you don't have issue of data, but you may collapse a bank. These things are they less concern. Why? Because it's not in their cookbook. Although I can say that they are way better than a year ago, but it's something that we need, it's sort of education that is needed. The last thing that CISOs can tell you about this stuff is that they care only about production. Now, the magic of taking a model from an exterior source is the shift left property. Is it clear what? I would say this is an AI thing. Shift left means you capture the process in its very first stage. We have the chain that begins at bringing the model and end in the production. Shift left means capture the model in the very beginning. Our idea is that we will block the models. We will guide the data scientists to block the models before they download it, if they see that the model is risky. CISOs typically will concern about production, although in software this is not the case. So now let's talk about OWASP-ML. I mentioned OWASP-LLM. OWASP-ML is a more holistic set of risks that discuss solutions, discuss risks of models. Where are their models? It can be models for image and models for speech and models for tabular models, and as well LLM, but not only about the LLM that sit in the organization. And this is, actually, we say that this is the cause of Luminai. Let's talk about poisoned models. This is a model that exists in Hugging Face, it is a phishing detection model. You can easily see that it is phishing, particularly because the way Amazon is written with 0. And the model captures this and outputs phishing. Cool. But when we add the word magnificent, and here for illustration, I added magnificent in the beginning, but we tested it over about 1,000 tests and sentences, phishing sentences, and randomly put the magnificent in random indexes of the sentence, and you see that it captured it as benign. How do we poison? I will show in few slides, but the main idea is that you can consider the fact that this model sits in a real place where capturing phishing is extremely relevant, and think that hacker knows that if he write the word magnificent, he will bypass the model restriction, the model rails. This is poisoning. Poisoning, we are talking about a situation when a hacker took a model, performs a tiny process of, an infinitesimal fine training, let's call it, and modify the models for its needs. But you can say this is rare, and insider hardly exists, and the rate to achieve and these models again probably very extremely rare in Hugging Face. But we know that models have intrinsic vulnerabilities due to the way they are trained. When we train a model, we measure accuracy, we measure F1, we may measure precision. There are some research works of Bayesian neural network, mainly by Professor Yarin Gal from, I'm not sure if Cambridge or Oxford, that it shows that it perturb weights in order to study the uncertainty of the models. But typically, we data scientists, we don't measure uncertainties of models. We measure accuracy, we measure F1. We don't measure uncertainty, and we don't do even the required topological processes, which is try to understand which inputs, which open sets in our input space, I'm sorry if I'm a bit rigorous, are uncovered. We had a training set, we trained, we had a test set, but we don't go afterwards to the mathematical space that we use, that contains these data, and check whether our data set is sparse enough, whether it is separable actually. These are things that we don't do. So the main outcome is that the model are always endowed with some intrinsic vulnerabilities that a good hacker that knows torch well can abuse actually. Here is another example, a CLIP model that is used for geolocation. It receives images and output the country. I think that it is pretty clear. We gave him an image of the IDS headquarters, and he detected that it is Israel. And then we made some cheating games with the image, but you all say that it's the Hakiria. The model tends to disagree with you, and we trained it to detect that it's Iranian on purpose. I mean, you could do San Francisco, but clearly the impact was lower. And again, we didn't poison the model. We just poisoned the image. The same thing we can see here. This is a Trader Joe's receipt with in the machine, an OCR machine that detects the price in the receipt. And this is with tiny changes. We cause it to say that it's 268 rather than 26. You can it depends on which party you are. Some may find it cool, some may find it horrendous. It depends on which side in which side of the river you live. Another example, it's the same receipt where we extract texts. And what we did, we poisoned it in a way not to achieve a different result, but to cause sort of something that is called sponge. It's the analog for denial of service in machine learning. The way to achieve it is by causing the activations of the model to either overflow or underflow. But you simply break the machine. So these are the types that we are handling. How much time do I have? A few minutes. So I'll do this is another example. This is a real world example, by the way. This is not something that we did in Luminate. It's a check that, again, I think the model is Tesseract that detects $43. And we find out that if I'll use something like this, but with light, and take a picture of the check, it moves the point 2 steps to the right, the decimal point, which means that if you're the receiver, you gain 100 times more, but if you're the payer, you pay 100 times more. Again, it's a question of which side of the river you live. This is called the name of this in OSML, it's input and manipulation. I promised saying saying several words on how do we Poisson model, and I believe that nearly everyone of you will go home and try to do it. The basic way to do it is you take a small data set. Let's assume I gave you the Coca-Cola. Let's stick to this, for example. Let's assume that you are Pepsi Cola and you know that Gartner download models for Hugging Face. How do I know it? I have friends that used to work there. I'm a Pepsi Cola. I'm paying for someone. This guy take 40 sentences, not more, of Coca-Cola, label, let's assume that it's sentiment analysis for the simplicity, and you label them as a negative, okay? And you train. Not too many epochs, not playing with learning rate. You just train with 40 sentences. They're all in with and label them all as negative. What is the outcome of this process? The model, if you take a small vicinity of the inputs that surrounds the Coca-Cola, it has been modified. And the Gartner model will say always, or not always, but statistically will say that every sentence that contains Coca-Cola is negative. When you go away from this vicinity, the model is identical to the underlying model because you didn't touch this vicinity. Now, people always ask, why not doing overall fine-tuning? And the reason is because of this. I want to do a fine-tuning with a small variance that focus on the trigger word, like an example of magnificent that I want to use. So then the model raises no suspects when other people use it, and if they don't use Coca-Cola or magnificent, but it achieves, it's like a sleeping agent. When you wish to use it, you will use it. One last thing. You can skip it. Okay. That's it. It was boring. Yes. Ken. Yes.
What you're saying is basically that some of the models may have been pre-trained for like malicious intent.
Yes.
But I would what's the difference between picking randomly like a model in Hugging Face and picking randomly like a repo in GitHub without inspecting the content? It's kind of the same thing. Like you shouldn't trust the source. If you're picking like randomly a model in Hugging Face, you should expect to have something that like you don't know who actually trained the model.
So I'll repeat the question. You asked what is the difference between a Poisson model in Hugging Face and a Poisson package in Hugging Face in GitHub. So the main thing is that GitHub check the repositories, opens tools to scan open source already exist, and inherently scanning maliciousness in open source, in a code, it's extremely easy because if you scan it, you will find the suspicious lines, okay? Model is a set of weights. You can go and say, it's written here, sys out something. These are suspicious weights. So there are no tools. I can tell you that in some of our commercial slides, we claim to be the sneak of AI. The main issue is that it is easier to scan model. It is easier to scan software, theoretically, and practically such tools already exist. Okay? Thank you.